Hi everyone, welcome back today. Today we'll be talking through exercise 4. So this is right after lesson 4. And this is where we're going to start learning how to take our big chunk of data that we have to train with and actually break it into a smaller piece for validation and then a big piece for training. And we'll do that today. To recap what we've done so far, so this is exercise 4, model validation. This first bubble here, this first code bubble here, is we're going to import pandas as PD. So pandas is that library that allows us to handle data easier. We're also going to import our decision tree regressor model from a library called sklearn, and inside sklearn there's a section called tree. So inside sklearn tree is a decision tree regressor model. We're going to import just that model. We could come over here and put import, get rid of this from part, and just import the entire sklearn library. Then we would have everything we need in there. The only problem with doing that is sklearn library is huge, and it's going to make our file run really slow. So we want to avoid doing that whenever possible. So here we're just going to bring in the one thing we need from sklearn.tree. Tree is, you can think of like a folder inside of sklearn. It's a little section in there. Then we told we found where our data was. So our training data, train.csv, all 130,000 houses and all their features are in this file in this location. We saved that to a variable called Iowa path. Then we used the Panda library and we used the read-csv function in the Pandas library to read the path, the CSV, and convert it into something called a data frame. That's what's happening with this PD command right here. And that data frame is now called home data. So we have all of our data now converted from a CSV into a data frame, which our machine learning model can use now. And we have all that data stored as home data. Then we need to tell it, hey, what are we predicting? So the thing that you're predicting is saved in a variable called y, or a data frame called y. It has to be y because that's what the model is looking for as it does its work. And we're going to use the sale price. So really before we did this step, we would have a step just before this that would say something like home data dot columns. And that would show us the names of all the columns. We would look over those and find the one that we want to predict, in this case the price. And we'd look and spell it exactly the same way. So the column name in our home data column is sale price with capital S and capital P. That has to be perfect. So this says, go to the home data frame, find the column called sale price, and save all of the data in that column into a data frame called Y. So now we have a data frame called Y with one column in it of all the sale prices for all the homes in order. All right, next thing we need to do is decide what features that we're going to use to try and predict the home price with. In this case, we're just going to use these features. So lot area, year built, first floor, second floor square footage, full bath, bedrooms above ground, and total rooms above ground. These may not be the best ones. In future lessons, you're going to be able to delete some of these, add more of them, and change around what features you're using, and then test your model to see if you've made a better model or a worse model. And that's what data scientists do. They try stuff and see how well it works. All right, now that we've identified which features that we're going to use to do the predictions with, we need to get them and put them in their own data frame. To do that, we use this code here. We say home data, that's where all of our data is stored at, and go get all of the feature columns. So we've saved these names of all the columns into a list called feature columns, and now we're going to get those feature columns and store all the data in those columns in the home data frame into a new data frame called X. So this data frame won't have the prices in them, it'll just have those things we're going to try and predict with. All right, so far so good. It's also critical that these names of these columns exactly match the actual names of the column. All right, next thing we're going to do is we're going to actually create a model. So we're going to create the decision tree regressor. We're going to use that model. We're going to save that empty model. It's kind of like untrained yet. Save it into a variable called Iowa model. So now our Iowa model is our decision tree regressor. Then we're going to go Iowa model.fit, and this is where it's going to actually start trying to adjust the way the model works to try to do the best predictions possible. And we're going to fit it using the X stuff trying to predict the y. So now it knows what it's trying to predict with and what the predictions are supposed to be, so it can try to start predicting stuff and see how well it does. All right. This next 2 lines of code are just things that we're doing just for today's lesson. They're not things we would normally do. First, what it's going to do is after it's been fit, it's going to take all of that X data that we just fit with, it's going to run it back through the model and do a prediction using it. And then this next line of code is going to actually predict out the actual Y values. Now what we're going to find is that, well, in just a second. Next thing, this next part, you can kind of ignore it. This is just for these lessons in Kaggle so that they can run these codes that say stuff like step 1 check. So these won't work unless this code is run. So this is what sets up all of that. So I'm going to come up here and just hit play on this code and let it run through real quick. It'll start my session and then run all of that, fit the model, do all of that work. And when it's done, it should print these 2 lines down below. Maybe should have started this sooner, sorry. Here we go, all done. So notice it printed these words, first in sample predictions, right here. So these are the predictions that the model made based on the X data. And you can see that then this next row are the actual values. And you can see it's actually so far, like everything looks like it's predicting perfectly. But this, when you use the same data that you train the model with to test it, it's going to do really well. It's like playing Jeopardy after watching the episode once. You're going to do a lot better after watching it once because you've seen all the things. Same thing here. The model's seen all of these homes already, so it knows how to handle them already. So it's a cheating way of doing it. What we need to do is before we train our model, we need to break out some of the houses, like maybe 10% of them, and hold them off and don't train with them so that we can use these that the model has never seen over here as a way of testing whether the model is any good or not. That's what we're learning about today, how to do that work. Okay, hopefully that makes sense. So let's go through the exercises. So this is where we're going to actually go back and we're going to split our data. To do that, we're going to use a function. So I'm going to delete this because the little hashtag here creates a comment. So I'm going to delete that to give me a comment. We need to import from sklearn. Oop, no capital L there, sorry. From the sklearn library, we're going to import from the model selection section. So sklearn dot model underscore selection. And we're going to import the thing called train test split. Train underscore test underscore split. Right? And this is, we just got this from the lesson. So I went back and looked at the lesson and got this code. This is where it's stored at. All right, so I'm going to leave this fill thing because this is a comment. So I'm going to come down here and do and undo this one. This is the actual code. So in Python, if you want to create multiple variables, you can just say the name of the variable. You don't need var, which is kind of cool, but also kind of crazy. You don't need anything to tell it's being created. You just do train x, comma, val x, comma, train y, comma, val y, comma. It makes all 4 of those variables. And then we're going to put the code from train test split here. And that code is just train test split with an open parentheses and then x and y. So these first 2 parameters of this function tell you where all of your data is. So currently the data is stored in x and y, all of it that we want to use. And then we're going to go random state, underscore. And we're going to set that equal to 0. You can set it to equal to any number here. Remember, all this random state, setting it to a certain random state, means that if I rerun this code bubble, I'm going to get the same results because it's starting at the same random starting location. Whereas if I don't do this, I'm going to split the data differently every time. All right, so here's what this train test split does. it takes all of the X, all of the feature, the data frame for all the features, and it pulls out like a random 10% of that and stores that random X into a validation X variable. And it puts the other 90% into the train X. So now we're training with a bunch of data, but we're holding back some of it so we can test it later with it. And the same thing will happen on the Y. It's going to take 10% of the Y values, the same 10% I took of the X, so they'll match up with each other. It's going to store those Y values in the validation data frame, and it's going to store the rest of the 90% of the Y values in the training variables. So basically what we did is took a big X and a big Y and broke it down into a little bit smaller of an X and a really small validation set. So we made 4 sets out of 2. Hopefully that makes sense. So let's just do a quick check. I'm going to run this bubble. It's going to run step check, and it's incorrect. The training data at different rows than expected. All right, let me pause and figure out what my error was. All right, I didn't find the error, but let me walk you through how I'm going to go about thinking about it. So I'm going to come down here, and I'm going to unhide the hint, and I'm going to run the hint. Is part of sklearn. Okay, so that's that first part. When calling the function, the arguments are X and Y. Ensure that you set the random state to 1. Oh, interesting. Maybe the random state has to be a certain number. And let's set it to 1. And let's rerun that then. Let's see if that did it. So apparently the random state does matter. In the lesson, it had a random state of 0, and this one it needs to be 1. I don't fully understand why. I'll try and look into that. All right. So that part's working, so yay for us. Need the hint. Now we're going to actually specify and fit the model. So we're going to fit the model using only the training X and not show it the validation X. So we're going to do Iowa model, and down here we need to import the model. So we need to do decision tree regressor. So I'm going to pull this decision tree regressor model, and we've already imported that. Yep, so up here, we've already imported decision tree regressor into our folder, into our file. And now we need to fit it. So we're going to just do Iowa model. So I'm going to copy and paste this Iowa model here. And the fit command you may remember is .fit. Open parentheses, and what are we fitting with? Well, we're not going to use all of X and all of Y. We're going to use the train underscore X, comma, and the train underscore Y. So just the training portion of the data. I'm going to make sure I have those names correct. So, yep, train capital X, train lowercase y with underscores. Awesome. So that fits my model. And let's run this bubble and check to see if we got it right. Ensure you create with random state equal 1. Oh, decision tree regressor. And we're going to start here with a random state equal to 1. And then let's run the bubble again. Ooh, it did not like that. That's not where random state 1 goes. Let's just look at the hint here. All right, let's look at the solution then. There's just some simple error that we're making. Oh, I've misspelled random state. That's what it was. So it should be underscore state. I just typed it in wrong. Oops. There it is. Yay. All right. I'm used to using like this where it capitalizes each word, and a lot of this stuff is using underscores between words instead. So it's just a transition for me. All right, so we fit it. I'm not sure what it's printing and why. It's printing something on the check. So yay, I guess. All right, next is make a prediction. So now we're going to do some predictions. So we're doing validation data. So that's the val part of this, predictions. And what we're going to do is we're going to run a prediction using our model. So to do predictions, we're going to do the name of the model. So here it's Iowa data underscore data. Let me make sure I got that spelled correctly. Oh no, Iowa model, sorry. This is our model. I'm gonna pull it from here because that's where we fit from, it doesn't matter. So Iowa model, and then the code for that is .predict. So fitting was .fit, and this one's .predict. Now we need to say, what are we gonna predict with? What variables are we gonna use? Well, we don't wanna use our training X features. We wanna actually use our validation X. These are the ones that the model's never seen before. So this is gonna be more of a fair, so val underscore capital X. And let's go ahead and run that and see what mistakes I've made. Oh, correct, yay, 1 out of 3. So we're gonna run the val X data through the prediction, through the model to predict what the values are. And now we're gonna print them. So we wanna print, and we're gonna print in sort of this fashion up here. Oops, one more up right here. So you can see you can do print, you can do a string of text, and then a comma, and then something else next to it. So here we're gonna do, this is the top few validation predictions. And those are being stored right now. So we did a predict on val X and we stored them in val predictions. So we're gonna do, this is the predicted values. And I'm gonna do that in quotation marks. I'm going to put a comma in just like above there. And we're just gonna say, hey, we're gonna do the val predictions dot head. And that's gonna give us those first, 5 or 6. Dot head, the only question is, do we need the open close parentheses for the dot head? But we'll find out in a second, I guess. And then here we're gonna print the actual values. So here, these are the actual values. Comma, and on this one, we're gonna actually do the validation Y dot head. Okay, and let's run it. I think I need the open close parentheses. I do, that's what it's telling me. So head needs open close parentheses to work. And let's rerun that and see. Still does not like that. Let me pause and see if I can figure it out. Okay, so here's what I found out, is that this val predictions isn't a data frame, and a data frame is the only thing that has a dot head with it. It's a different kind of value, so it's like a list or something, and it doesn't have a dot head to it. So what I just did predicted values, and then printed all of the predicted values. So these are all the predicted values in order from first to last. And then the next thing is actual values, and this one is a data frame. It's just stored like that from the model. I don't know why. So dot head works with it, and then I shifted over and put it out as a list to list. You wouldn't even know how to do these things. Don't worry about the details here, but that's what it looks like in the end. And what we can do now is say our first predicted value is 186,500, and the actual value for that house is 231,500. So pretty far off, not a very good model right now. Our second house the actual value was 179,500, and the predicted value was 184. So that one's not too bad. That's only off by a few $1,000s. So that one's not too bad. And then the next one was $122,000 was the actual value, and this one was 130 predicted. So again, not terrible. The next one was 92,000 and 84,500. Okay. 142 for the last one was the actual value, and the predicted value was 164. So that one's pretty bad. That one's off by $20,000. So you can start seeing how now, because we're sending in new data, the validation data, we're actually getting a real view of how well our model is performing. All right, so the next bubble is gonna do an actual measure. So I'm just comparing it visually to see how good it is. We're gonna do some math on it. So from sklearn.metrics, we're going to bring in the mean absolute error function so we can use it. To use this, we have to we're going to do, so val MAE is the variable we're going to store the thing in. We're going to use the mean absolute error function right there, same as this, open close parentheses. And what we need to do is we need to give it the information it's going to compare. So we're going to do val y. Those are our actual values for the validation data, comma, and then we're going to give it the predicted ones, and those are being saved in this variable up here, val predictions. It's being saved right here. Actually, we did our predictions on all the x's, and we saved all those predicted values here, so val predictions. And we're going to compare that to val underscore predictions. And we're going to run that. And we have a correct, yay! And then we're going to actually undo this right here, and we're going to print the val MAE and see how good we did. And this is how far off we are. We're off by, on average, like $29,000. So $30,000 of error in there seems like way too much. We want that down into like maybe a few $1,000s of error. Right now, if I told you, hey, the price of your home was, $190,000 plus or minus $30,000, you'd be like, well, that could be 160 all the way up to 220. That's not very helpful range. So we've got a model that's working a little bit, but it's not very good. And so we're going to learn what underfitting and overfitting means next, and then we'll start playing around with different parameters to make our model better. Awesome, good job, hang in there.